Hello everyone, welcome to this week to the bi-weekly community call. Please, if you haven't already done it, remember to write your name under the Who Joined section here in the HackMD. I will show the HackMD in the. Oh, where is the chat? Yeah. Okay, I won't share it because I don't know where is the chat here. During this call, the CNCF code of conduct applies, so please be kind and gentle to everyone else. Last but not least, this call is being recorded, so if you don't want to your face to be recorded, please turn your camera off. Today, let me stop sharing and I will share the screen once again. Oh, thank you, Leah. Share. Is this? I don't know. Here it is. We go at the first. Okay. Today we're going to talk about the new container plugin that will be available in the next Falcon release. So historically, we always had many issues linked to the container support into libraries. Most of them were that metadata are not basically available as soon as possible. So there are many events, syscalls, where container metadata are not available and you cannot extract them. The biggest grid, this is the greatest impact of this is for short-lived containers, where you have a small container that runs a small process and then leaves, and you won't ever see. You will see it because the container ID gets started synchronously, but you won't see any metadata from it because the life of the container is too short for us to catch containers metadata in SYNSP. So given that the synchronous lookups is started right after the first event in the container, so when we are able to extract the container ID in the whole SYNSP implementation, that means that of course the very first event will never be will never have containers metadata available. Also, the containers list was protected by Mutex, and this is not good for performance reasons, of course. Instead, the new plugin implementation is subscription-based. It leverages SDKs provided listeners. Since we attach the container create notification, we'll have metadata in place before the first process is even started inside the container. This will make it very hard to receive events without container metadata attached. Here you can see the plugin architecture, and it's pretty convoluted because we got the C++, the API, the plugin API is implemented by a C++ plugin, but then we have a Go worker that does all the SDK listener thing, so that it attaches, basically it attaches listeners from various SDKs, and they communicate through a Go API that is exposed by Go worker, and the C++ side passes a callback that is going to be called by the Go worker to generate asynchronous events. The asynchronous events then are parsed by the C++ side, and then they enrich. The C++ side is able to enrich its own container cache, and then is able to extract, of course, the related fields. Oh, I forgot to mention that the plugin capabilities set of the plugin is fully composable at build time. So you can decide to only build, for example, you can only build the extract and the parse capability if you're going to use the container plugin, for example, to just enrich the read of SCAP files, and you won't need the synchronous capabilities or listen capabilities in that case. So you can get a much more lightweight plugin for that. Okay, that is not the case for the Falco shipped plugin, but I wanted to specify it. So this is the very first benchmark that I ran of the plugin against the old SIMSP implementation. It is pretty simple. What I did is that I exported the feeds from the plugin with a new name. In this case, it's container underscore plugin instead the container. So that I was able to run the container plugin side by side with the SIMSP implementation. And what I saw is that when when I created a Docker container on my system, the very first syscall, that is a clone exit here, we already had the image from the plugin, so the plugin already had metadata available, while SIMSP took around 100 milliseconds more to fetch metadata. Here we can see it. This showed that the plugin implementation was really promising, and it seems to work pretty fine. Another thing here is the Falco 0.30.0 output for a short-lived container. I used patched rule to trigger that this container was spawned event. And as you can see, the very first the event has no container name available because metadata is not available yet. That is because, as we said before, this is a very short-lived container, and we are not able to fetch metadata in time with all the SIMSP implementation. And now we can see instead that the Falco master that uses the plugin, as you can see here, not in plugin container, also has the container name available because, of course, we now have full metadata available as soon as the container starts. I think that's like everything from my side. I don't know if you want to dive deep inside my plugin, or if you have any question, please feel free to ask me.
I have just a question, but I already know the answers, just for the audience. Is this new implementation fully compatible with the old implementation? I mean, does users does users need to update their rules or change anything?
Not as you can see here, the only breaking changes are that the muzzle build will lose support for container metadata because it is not able to runtime load plugins, and that the Falco security SCAP and containers and missing container images matrix will use the new Falco security plugins prefix because they now live under plugin and not under SCAP. There is no other breaking change.
Perfect. Thank you. Very last question. How can people try this? I mean, we have a developer preview, right?
Exactly. The Falco master image is already shipping the plugin. As I stated here, we decided to bundle the plugin within Falco at least until 1.0.0 to avoid any breaking change for people using RPM and Debian based installations. So you can even try to install a Falco from RPM dev or Debian dev bucket for packages, or you can use the Falco master image. It already ships the container plugin.
No other question. I just want to say you thank you for this because this is a very step forward in Falco development. As you mentioned, we had a lot of issue with the container runtime for a long time, and this fresh new implementation is very promising. Thank you again.
Thank you. Of course, expect some rough edges here and there.
Sure.
I expect everything to be fixed before 0.41. And also future work might involve porting users and groups management to a plugin too. And I think that then we will done with the SIMSP cleanups.
Wow, thank you.
Any other
I
questions?
have I have a quick question here. Are we going to do automatic validation on which container runtime is being used and just use that, or do we need to always specify, for example, that I'm using container D and then configure the plugin to point to the socket? How does this space work?
Okay. By default, we enable. Let me go here. Here. By default, we enable every engine with some default sockets. Of course, in case you're using these are the same defaults that we use in Falco 0.30 with the old SYNSP implementation. Of course, if you use different sockets, you can customize the init config for the plugin.
Cool. Awesome. Thank you.
You're welcome. Oh, let me drop the link to the container plugin. Oh, the real link to the container plugin. Sorry, because it has been donated. Here in the README, you can find many informations. That's all. If nobody has any more questions, I think we can call it a day.
I have no more question, but I just want to give everyone a friendly reminder. We will be at KubeCon next week. I mean, at least 4 of us. And let's join our maintainer track and also the project enlightening talk by Luca. Just this. Thank you.
Thanks, everyone. See you in a couple of weeks, or well, see you next week for whoever will be at London. And thanks everyone for your attention.
Thank you.
Thank you, folks.
Thank you very
Bye,
much.
Fede.
Guys.
Thank you, everyone.
Good job. Very good job. Bye.